This module will provide a general overview of the 767 electrical power system. It covers system operation and describes the automated features. Primary electrical power for the 767 is provided by an engine-driven generator located on each engine. The integrated drive generator, or IDG, contains a constant speed drive and generator housed in a common case. The generator is a spray oil cooled, brushless, self-excited unit. Electrical output is three-phase, 115, 200 volts at 400 hertz. It is rated at 90 kVA for continuous operation. Speed is controlled by twin hydraulic pump and motor assemblies. An axial gear differential assembly adds or subtracts rotational speed to maintain 12,000 RPM and a stable frequency of 400 hertz. The IDG is attached to the engine gearbox with a quick attach-detach quad ring. The IDG oil cooling system contains series-connected heat exchangers. The heat exchangers interface with the engine fuel system and dissipate heat into the fuel. A supplemental oil-to-air heat exchanger uses fan air as the cooling medium and provides supplemental cooling during descent and ground idle conditions. Servicing of the IDG oil is through the pressure fill fitting. Oil is pumped into the IDG under 5 to 15 psi. A prismatic go, no-go oil level sight glass is located on the underside of the IDG. On the flight deck, temperature information is provided on the ICAS display. A guarded switch on the P5 overhead panel allows for IDG drive disconnect. Reconnection is manual and can only be accomplished on the ground. A third generator is driven by the auxiliary power unit, or APU. It can be used during ground operations or in the air in case of IDG failure. The APU generator is rated at 90 kVA and is electrically identical to the IDG generators. Electrical system operation and protection is largely automatic. The generator control unit contains a microprocessor which controls automatic operation and protection functions for its generating channel. There are 3 interchangeable generator control units, or GCUs. They monitor IDG outputs, providing voltage regulation, and interface with controls and displays on the flight deck. The GCUs also interface with the bus power control unit, or BPCU, via digital data links. The BPCU monitors external power and coordinates the operation of individual sources to maintain system operation. The GCUs and BPCU contain built-in test equipment, or BITE, for system self-check and fault diagnosis. The BPCU contains a BITE readout display and operating controls. Each engine-driven generator powers a main AC bus, one left and one right, through the generator circuit breaker. A tie bus and 2 bus tie breakers allow both buses to be powered by a single source, such as by the left generator. These buses can also be powered by the auxiliary power unit generator by way of the auxiliary power breaker, or by external power through the external power contactor. The APU can power either bus in the event of a failed engine-driven generator. System automation has simplified panel arrangement and operation. For example, generator controls are normally left in the in position for automatic control. Depressing and releasing the alternate action switch manually overrides the automatic system and opens the generator breaker. The amber off light will illuminate. Depressing and latching the switch again returns the system to the automatic mode. In the event the power from a generator is lost, the generator breaker will automatically open and the amber off light will illuminate. When a generator breaker opens, the system electronics automatically establish a new circuit through the AC tie bus. If no power is available, the bus off light will illuminate. If the AC bus tie switch is in the auto position, power will be transferred through the bus tie breaker automatically. An amber isolation light will illuminate when the bus tie breaker is opened, either automatically to clear a fault or manually by depressing and releasing the bus tie switch. External power protection and control has also been automated. When external power is connected to the aircraft, an available light on the electrical panel will be illuminated. This indicates that the cable is connected and the source power is acceptable. Ground service bus power is controlled by a momentary push-button switch located on the forward flight attendant's panel in the passenger compartment. Pressing the external power momentary switch closes the external power contactor and powers the tie bus. Bus tie breakers automatically close to power the right and left buses. This action also automatically trips any generator breakers that may be closed. With the APU started and running, the external power switch is again momentarily pressed. The external power contactor will open and the auxiliary power breaker will close automatically. When an engine is started and the IDG is running up to speed, the corresponding bus tie breaker will automatically open and the generator breaker will automatically close to power the AC bus on that side. The APU will continue to supply the other AC bus until the other engine is running. One generator can handle all essential loads. Utility loads are shed automatically if either generator fails or if the generator is overloaded. Transformer rectifier units, or TRUs, are powered from their corresponding AC buses. Each TRU can carry the load of both DC buses in case of a TRU failure. These buses are automatically connected by the DC tie relay. The main airplane battery is located in the main equipment center. It is a 24-volt nickel-cadmium Vinid battery rated at 40 ampere-hours nominal. It will provide standby power for 30 minutes to flight critical loads. Also located in the main equipment center is the solid-state static inverter. This unit is rated at 1,000 volt amperes and converts 24 volts DC to single-phase 115 volts AC for standby power. A guarded battery switch and standby power select switch are located on the electrical system control module on the P5 overhead panel. A second 24-volt battery is located in the aft equipment center to supply DC power for APU starting and operation. Both the main and APU batteries have their own dedicated charging units. These units are capable of recharging a completely discharged battery within 75 minutes. The electrical system voltage, frequency, and load information is displayed on the electric hydraulic page of ICAS. This concludes the overview of the 767 electrical power system. It has covered system operation in the automatic and manual mode.